Good afternoon, Robert Scribbler here, May 29th, 2018. So today I'm going to be talking about the recent severe floods that occurred over the weekend at Ellicott City, Maryland. And this was the second 1 in 1,000 year rainfall event to occur within just 2 years' time over the same location. But before we go into that, I just want to reiterate that we identified some factors during mid-May, including warm oceans and displaced polar air, as well as very high moisture levels over the eastern U.S., which were posing risk factors for very severe rainfall events. Now, we have since seen a number of severe storms moving over the eastern U.S. in various locations, and we've had a number of severe rainfall events and periods of severe rainfall. But the recent Ellicott City flood on May 27th is certainly a very severe outlier. So what occurred was that over the course of about 3 hours, between 6 and 9.6 inches of rain fell in the region of Ellicott City in Maryland. And this is just probably about 35 miles north of the DC area, in a location that has very steep terrain, so it tends to channel floodwaters into a downtown area and produce high risk of flood in the event that such heavy rainfall does occur. Now, to be clear, the amounts of rainfall that we're talking about are just insane. 9.6 inches of rain in just 3 hours or less is an extraordinary amount of rainfall. It implies that hourly rainfall amounts peaked at above 3 inches per hour and probably hit 4 inches per hour during this event. And just to give you an idea of context, a 2-inch per hour rainfall event is very intense. So this is beyond very intense. And as a result, we saw very severe damage throughout Ellicott City again, just 2 years after a very severe storm struck this region in 2016. So what the heck is going on here? Why is Ellicott City getting hammered? Why are we seeing so many severe rainfall events over the eastern U.S.? Well, the short answer is that the climate in the North Atlantic region and over North America is changing due to human-forced warming of the globe and regional effects that we expect to occur as a result of that warming. In the North Atlantic in particular, what's happening is that Greenland melt is starting to develop a cool pool in the North Atlantic, and this is developing a trough throughout the region of eastern North America and the North Atlantic. The second factor involved is a warming of sea surfaces as the Gulf Stream slows down, both in the Gulf of Mexico and in the middle latitudes of the North Atlantic. And these warming sea surfaces produce a massive amount of moisture that flows into the eastern section of the United States, as well as tends to generate warm conditions over the central U.S., and this juxtaposition of cold and hot tends to result in unstable weather patterns. Now, what occurred on May 27th is that we experienced a backdoor cold front sweeping in over the northeastern U.S. And so this is a model depicting May 27th. And as we can see, and this is a temperature anomaly map. It shows cooler than normal conditions and warmer than normal conditions, cooler than normal in blue, warmer than normal in red. And so what we see is that you have these warm temperatures in the central U.S. and these cool temperatures starting to dig in over the northeast. And as we advance in time toward midday, you see these cool temperatures invade through New England, down into Pennsylvania, and juxtaposing the region of Maryland here. So you had a backdoor cold front sweeping in and facing off against moist, warmer than normal air to the south. And this produced a number of very severe thunderstorms, the most severe of which popped up over Ellicott City and produced substantial flooding. We'll also take a look at the jet stream here. So here's the trough that helped to produce the backdoor cold front, and this trough is also in association with the cool pool over the North Atlantic. And I'm also going to show you the atmospheric moisture levels over the region at the time. So here we had in place tropical moisture levels over the eastern U.S. in association with very warm sea surfaces, a high pressure system circulating over these very warm sea surfaces over the eastern U.S. and pulling in that moisture, and in addition, a tropical flow over the Gulf of Mexico associated with a tropical storm, and we're going to talk about that a little bit in a different post, which was also providing a bit of moisture kick to the region. And as you can see with this dry line here, there was a backdoor cold front moving in and providing instability in this region. So in short, we had two 1 in 1,000 year flood events in the past 2 years as a result of a new climate pattern that is caused by human-forced climate change. Now, if you have any doubt as to the dynamics with regards to North Atlantic ocean circulation slowdown and the resulting cool pool in the North Atlantic, I'd like to refer you to Dr. Stefan Rahmstorf, who wrote a recent article in Real Climate about how AMOC, or the North Atlantic ocean circulation, is weakening and how we have numerous proofs at this time pointing to this. And as you can see, the slowdown is not simply an abstract. It has real-world effects. And in the case of Ellicott City this weekend, those effects were devastating.